Welcome to the LemnaTec Academy. In the last video, we submitted it and executed our first analyses. Today, we look into the results of these analyses. You find the analysis results at two places. The numbers can be evaluated further in the results section. More on this in a second. The results images can be inspected on the recordings page. First, we have to open the experiment and some snapshot that has been analyzed. You notice the bar between the images. On the left, you have the recorded images. But on the right, you have the images created by the analysis. If we enter the results section of LemnaExperiment, we see that we have again two subpages, named Results Table and Graphs and Plots. However, on the results page itself, we got a box for each analysis experiment combo. In this box, you find a plot which shows you the progress of your experiment using the data columns selected by some heuristics. The more interesting pages are the two others. First, we have a look at the results table page. At first glance, we can't see a lot here. This page is rather empty. This is because analysis results can be huge and therefore somewhat slow to load. Therefore, picking some data set by some heuristics may cause unnecessary delays. So you have to select first some result data set. This is done by selecting an experiment and an analysis definition. And then the data appears in the table. This table has a lot of columns. Therefore, these columns are color-coded. Green for columns identifying the sample, blue for columns containing the recording time and related timestamps, white for the actual analysis results, orange for sample annotations, gray for more technical columns. You can filter the data by each column with the menu below the column title. You can sort the data in the table by every column. Just click on the column title. With the menu at the top right, you can select which columns shall be shown in the table. Finally, you can export the data to a CSV file with tab separation. You can change the separator of the CSV file in the settings if you prefer another one. If you check the Export as Filters box, only the currently visible content of the table is exported to the CSV file. One more note on the displayed data. This is the joint data from the annotations and the analysis results. Therefore, this table includes samples which have been annotated but not yet analyzed. You can identify them by the value NAT in the analysis time column. NAT stands for not a time. You may have noticed it is possible to select more than one analysis definition at a time if available. If you do this, we have to merge the results for the two or more analysis definitions into one table. There are two ways of doing this, which you can select by the merge mode. With the side-by-side mode, We create new result columns for each analysis definition. You can find them both in the table. So if you have two analysis definitions, creating result columns with the same name, you get two columns in your table. If one snapshot was not analyzed by one of them, these columns may contain a not available value. Which value this is depends on the data type of the column. The other mode is the newer data overrides mode. If two analysis definitions create a result column with the same name, we will have only one result column in the table. This column contains the values from the newer analysis based on the analysis timestamp. One more technical remark. In order to improve speed for larger data sets, this page uses cache files, which contain prepared table data. Usually these are updated automatically. However, if not, you can trigger this update with the Rebuild Cache File button. Let's continue with the Graphs and Plots page. Like with the results table, we first have to select an experiment and an analysis definition. And like with the results table, we may merge multiple analysis definitions in the same way. The data used for these plots are the same as displayed in the result table we've just seen a moment ago. Once you selected an experiment and analysis definition, the first plot appears. LemnaExperiment selects the X and Y axis using some heuristics based on the type of the data and their origin. Origins can be analysis results, annotations, timestamps, etc. Data types can be timestamp, time difference, text, categorical, integers, and floating point numbers. The latter three are differentiated in types with few distinct values and with many distinct values. There's one special column which is created automatically by LemnaExperiment. It's called Time Since First Recording. This is the difference between the snapshot recording time of the current snapshot and the recording time of the first snapshot with the same vessel in this experiment. This way you can align times for different samples which have been recorded at different dates and times. For instance, maybe you could not afford to execute the whole experiment at once, so you run one half of the samples in April and the other in May. Using only recording timestamps, any plot versus recording time will restart halfway through the time of the experiment. Using time since first recording aligns both legs of the experiment. You may have noticed the plot type is selected automatically by a similar heuristic. This plot type heuristic is activated if the plot type is set to automatic. There are other plot types available: line plot, scatter plot, bar plot, box plot, heat map, violin, and pies. Some of these plot types work only with certain of the aforementioned data types. For example, you cannot use a bar plot with bars over floating point data. This needs to be categorical data or integers with few values. Of course, you can select which data column is plotted on the X and Y axis as well. The available data columns include all result and annotation columns, as well as some timestamps and some more technical columns. Depending on the plot type, you may even select multiple data columns for the Y-axis. Below these controls, you find three tabs. On the page of these tabs, you can fine-tune your plot further. The first tab is for grouping data in the plot. Let me give you an example. We start with plotting damage data over cultivar in a box plot. Then we group by infection. Now we have three boxes for each plant type, differentiating between the different infections. The second tab contains plot-specific parameters. These differ from plot type to plot type. For the box plot, we have use average instead of median, show the average marker, choosing which parameter is used for the whiskers, where to place the legend, and showing the outliers. The third tab allows us to aggregate values along the x-axis. This is easiest demonstrated again by an example. Let's plot damage data over time since first recording as a line plot. This does not look as expected. The reason is we have multiple data points at each point in time, which are now connected by a line. Let's check the scatter plot for confirmation. So there we have the mess. Multiple data points at each point in time. But if we return to the line plot and activate data aggregation using an interval of 1 hour, the plot looks more like what we expected. The data of each recording run is now averaged over an interval of 1 hour, and we have one data point per day. Note, not all these tabs are available for all plots. For instance, the aggregation was not available for the box plot, as you may have noticed. You can select the samples to be plotted in more detail as well. This is done using the filter menu at the top. You can filter by almost every data column. By default, one filter is activated. This filters out the data from any snapshot which not have been analyzed yet. This is done by excluding data points with an analysis time of NAT. With this experiment and analysis definition pair, we have no snapshots which not have been analyzed. Therefore, we have no analysis time of NAT. If you have a particularly useful setting of plot parameters, you may save these in the database using the Save button and load it later on the same or another dataset. Now we load another plot and return to our saved plot. Let's have a final look on the plot itself. On the right, we have 6 more buttons. The zoom button, which activates the zoom mode. If in zoom mode, you can draw a rectangle on the plot to zoom into this area. The pan button, which activates the pan mode. In pan mode, you can drag the plot around. On new plots, neither of these modes are activated. The home button, by which you return to the original view of the plot. A new view is created when you use the pan or zoom button. This history of views is resetted each time you make a change to the controls on the left and the top. Forward and backward buttons are to navigate through the history of these views. And finally, the Save button, which you can use to save the current plot to a PNG file. Sometimes you need more than one plot to assess the outcome of an experiment. Therefore, you can add more plots to this page using the plus buttons at the right and at the bottom. Here's some useful plots. You can also change the space occupied by the different plots. If there's not enough space on the screen, you can extend the space by dragging the outer blue bars. This extends the plot canvas at the expense of global scroll bars. You need to move the bar to the right, even outside the window. The area increases as long as you move the cursor. To reduce the area, move the cursor beyond the next inner blue bar. Increasing the size to the bottom works the same way. You can change the position of each plot by dragging the drag icon to another location. The two plots swap then spaces. And finally, you can close plots using the X button. If you want to reuse such layouts of multiple plots, you can save them to the database in a similar way as we did before for the plots themselves. If you don't need the controls of the plot, you can hide them using the checkboxes at the bottom. This applies to all plots in the current layout, hiding the filter section and the controls on the left. The latter is a tree state checkbox. This was the last video about LemnaExperiment in the second class of our software training videos. In the next video, we will have a first look on LemnaGrid. See you there.